All right, so let's look at, which one do I want to look at? Yeah, so look at the piston cylinder device contains 0.005 meters liquid water. So this one is what we're going to look at. Okay. The other one in the back, I believe I have a video that you can watch online for additional problems. And I'll post like 3 or 4 additional problems online for you to go through. So what we're going to do is it's like a problem that uses the vapor dome and tables to figure out properties. All right, so the piston cylinder device contains 0.005 meter cubed of liquid water and 0.9 meter cubed of water vapor in equilibrium at 600 kilopascals. Heat is transferred at constant pressure until the temperature reaches 200 degrees C. So, first, let's write some givens. So, contains 0.005 meter cubed of liquid water. So, let's say, I don't know, what do we want to call this? Big V of F, 0.005 meters cubed, and big VG is 0.9. So draw a vapor dome. And we're going to do pressure versus specific volume this time. So initially, it has those two values. So where are we on the vapor dome? Yeah, we're in the middle. Yeah. Okay. Then it says heat is transferred at constant pressure. So what's that look like on this graph? It's going to be a line. So just draw the line. Now we don't know for at the end, are we still wherever? We don't know yet, right? But we know it's a constant pressure, so we're going to draw. So T1 we don't know, whoops, but we do know T2, which is what? 200 degrees C. So we're going to find, what are we looking for? The initial temperature, total mass, the final volume, and we're going to show it on this process. Solution. Let's find T1. If we're in the middle, what is your temperature? It's constant, and it's the Tsat. So T1 equals Tsat, and it's at what pressure? 600? Oh, I forgot to write that in the givens, right? I was like, why don't I have it? So I'll write that in the givens. So I broke a rule. I'm just going to put it right here. So when you look up the table, you get 158.8 degrees C. So hopefully you notice something. T1 is 158. What's T2? So where are you? It's no longer a constant temperature, so you have to be out here somewhere. Because once it passes that saturated vapor line, what happens now? The temperature increases. Yep. So I'm going to say, all right, I'm going to skip the mass for now. Let's find the total volume. What do we know at state 2? The total vapor. So P2, and we know T2. This is 200 degrees C, and P2 is 600 kilopascals. And actually put a subscript 2 for your volume, because we're at state 2, the end. So start putting numbers on your states. What's going to help us to find our big volume from the tables? What can we find? We could go back to tables, and what can we find? We can find little v2, right? So if you go back and you look up table A-6, you will find that the specific volume is 0.352 meters cubed per kilogram. And then how do we find big volume? You need mass, okay? So big V2 equals mass times little v2. And now we need to find the mass. So we'll get back to the equation in red later. What I wanted to show you is if you know two things at any state, you can find anything you want. Okay? Well, how do we find the mass? Well, this is something new, but you could kind of put two together. It's the mass of the liquid plus the mass of the vapor. Or no, what do we call it? Vg, right? Vg, right? Yeah, let's call it Vg.
Yeah.
So at state 1, as long as we know the mass of the liquid phase and the mass of the vapor phase, we now know the total mass. Is it a closed system? Yep, so the total mass is always the same. Well, how do we find MF and MG? Well, it's big VF over little VF plus big VG over little VG. Where do we find VF and VG? Tables. Find them in the tables. Okay, so table, I believe it's either A4 or A5, depends on what you want to use. VF 0.0011 meters cubed per kilogram. VG is 0.3156 meters cubed per kilogram. What pressures are we looking at for those? 600 kilopascals, okay? So pressures, you want to use table A5. Temperatures, use A4. And just to save some time, once you plug the numbers, you get 7.395 kilograms. And then finally, your volume 2 becomes 2.604 meters cubed after you plug in the two values.